students, today we'll discuss about the coordination entity, central atom, some definition of some we can say important terms in coordination compound. So first we are discussing about the coordination entity. A coordination entity constitutes a central metal atom or ion bonded to a fixed number of ions or molecules. So suppose in that condition, one example is given to us, COCl3 NH3 whole 3. So at that condition we can see the CO means cobalt, that is actually this is central metal atom and that is surrounded by 3 chlorine atom and 3 ammonia molecule. So that's why cobalt ion is surrounded by 3 chloride, that is actually called the chloride ions we are saying, and 3 ammonia molecules here, and that's why this total is called coordination entity. Okay, so other example is there nickel tetracarbonyl, that means 4 carbonyl groups are there and with nickel. So this is total is called, actually nickel is a central metal ion, and here platinum is a central metal atom and atom or ion, and this chlorine 2 chloride ion and 2 ammonia molecule, they are surrounding it. So this is total is called coordination entity. Then it is coming about the central atom or ion. In a coordination entity, the atom or ion to which a fixed number of ions or groups are bonded in a definite geometrical arrangement around it, it is called a central atom or ion. For example, the central atom or ion in the coordination entities, just like example nickel. This is nickel, here nickel, cobalt and iron. So nickel 2 plus, cobalt 3 plus. What is the charge also, that we can count from this coordination entity also, we can find out from here. And iron Fe3 plus respectively, these are central metal ion here, and they are also referred as the Lewis acid. Lewis acid, why? Because they can accept the electron, they are able to accept the electron, that's why they are called the Lewis acid here. So this is about the central atom or ion. The next one is coming ligands. What are the ligands here? The ions or molecules bounded to the central atom or ion in the coordination entity are called the ligands. These may be simple ions such as Cl-, small molecules such as H2 or NH3. Molecule भी हो सकता है और ion भी हो सकता है. Larger molecules such as this is NH2, CH2, CH2, NH2 means ethylene diamine. What is the name of this compound? Ethylene diamine. Or NCH2, CH2, NH2 whole 3, even macromolecules such as the proteins. ये भी हो सकता है. These are also can be counted as the ligand. So just like that we can say here, when a ligand, just FeCN whole 6. So CN is the cyanide is the ligand here, and Fe3 plus is the we can say the central metal ion here. Okay, in that way ligands also we can count here. When now the varieties, the types of ligands you have to discuss here. When a ligand is bound to metal ion through a single donor atom, as with Cl-, H2O or NH3, just like this one, FeCN whole 6. So what is the center? We can see here the ligand is bound to a metal ion through a single donor atom, that is Cl-, H2, NH3. The ligand is said to be unidentate. When a ligand can bind with 2 donor atoms, as in ethane 1,2 diamine or ethylene diamine condition, just like example we can see here, that is CH2 and here it is coming CH2 and here it is coming NH2 and NH2. So here you can see this is ethylene diamine and here nitrogen, they are having the electron. So by this electron they can actually attach with the central metal, we can say ion or atom. So that's why this is called didentate condition. Why? Because one ligand, but they are attached with the central metal atom by 2 nitrogen here, 2 options are here. That's why it is called the didentate condition. Didentate means by 2 side they can attach. That's why it is called the didentate condition. And then it is coming about the oxalate. If we are coming about the oxalate, C2O4 2 minus. So here also we can say COO minus and COO minus. So definitely they can attach by 2 oxygen here. So 2 oxygen here, electrons are there. So definitely we can say these are didentate, means they are attached with ligand at a time by 2 we can say donor here. So that's what is called the didentate condition. And when several donors are present in a single, we can say the single ligand, several donors are present. Just like we can example, you can give here the slides. We can say that EDTA. What is the meaning of EDTA? I am showing that one. EDTA means I am just drawing the structure first, then I am showing. CH2 C double O minus, again for one more N is here, that is coming CH2 C double O minus and CH2 C double O minus. It is called ethylene diamine tetraacetate. What is the full form here? EDTA. Ethylene for CH2 group, and diamine, N and amine, again H is replaced H2, and that H2 means total H4 is replaced by acetate group. That's what is called ethylene diamine tetraacetate. So you can see here 1, 2, 3, 4 for oxygen. Again for nitrogen, how many are there? Again nitrogen 2 are there. So definitely 6 conditions are there. That's what is called hexadentate condition. Means with one central ion atom, they are attached with how many dent are there, how many we can say that donor are there, 6 donors are there. That's what is called polydentate condition. Polydentate condition. We can see the example afterwards also. So here it is 1, 2, 3, 4, 5, 6. That's what it is called hexadentate condition. Hexadentate condition. So this is actually just didentate condition. This one is also we can say this hexadentate condition. This one is also, this is didentate condition because only nitrogen can attach, nitrogen can donate. So that's why these are actually on the basis of that ligands are classified unidentate. जैसे Cl जैसे एक ही से attached हो सकता है. So that's what is called the chloride, we can say the cyanide. They are attached with a single. So that's why they are called the unidentate condition. Chloride, ammonia, H2O, Cl minus, NH2, you can say the NH3, this is amide condition, NH3, and next one is coming about the H2O. So they are called unidentate condition. Okay, so these are unidentate, didentate and polydentate on the basis of that how many donors they have to bind with the, they can bind with the central metal atom or ion. That's what is called the on the basis of the dentate condition is coming. When a di or polydentate ligands use its 2 or more donor atom to bind a single metal ion, it is said to be a chelate ligand. Chelate means, suppose this one is coming about the hexadentate condition, and there this hexadentate condition they are attached with 2 or 3 donor at a time. 2 or more donor atoms to bind a single metal atom, that is or ion, that is called actually the chelate ligand. The number of such ligating group is called the denticity of the ligand. Such complexes called chelate complexes tend to be more stable than the similar we can say complexes containing unidentate ligand. For reason we can see that one under after section 9.8 after us will discuss that one. So definitely ligand and we can say that chelate ligand. Chelate ligand means when the ligand uses its 2 or more donor atoms to bind with the single metal atom ion, that is actually called the chelate ligand here. Next one we are coming for ambidentate ligand. What is the meaning of ambidentate ligand? Ligand which ligate through the 2 different atom, it is called the ambidentate ligand. Just example you can see here, जैसे ये है nitrito and this is one is nitro O, nitrito N. Nitrito N means when nitro group, when in case of NO2, जैसे NO2 or SCN thiocyanide and NO2 group, when they are entire or we can say they are ligating with the central metal atom by nitrogen. This is the metal atom. When they are ligating by nitrogen, that then the name will be coming here nitrito N. And same we can say ligand when they attach to the oxygen, because both they can donate the electron. Nitrogen also can donate, oxygen also can donate. So when oxygen is attached with the metal atom, that is called nitrito O. And when it is attached with nitrogen, that is called nitrito N. So at that condition they can attach by 2 different atom, and that's why it is called ambidentate ligand. So it is that's in that condition we can say the nitrito O, nitrito N, we can say that one. Otherwise thiocyanate, it is called thiocyanate. SCN when attached with metal with sulfur, then it is called thiocyanate. And when it is attached with nitrogen, means same molecule but it is attached with 2 different atom. तो यहाँ पे सल्फर के साथ अटैचमेंट है, ये नाइट्रोजन के साथ अटैचमेंट है, तो इसको हम लोग क्या बोलेंगे आइसोथायोसानेटो. सो ये जो O is coming, that will discuss with the we can say the in nomenclature we can discuss that. So these are called actually nitro in case of the cyanide, thiocyanate ions. They are actually called ambidentate ligand because they can attach to the central metal ion by two different atoms. One time by nitrogen, one time by another time by oxygen, one time by sulfur, another time by nitrogen. So on the basis of that, they are called ambidentate. Next one, we are coming for the coordination number. What is the coordination number here? The coordination number of a metal ion in a complex can be defined as the number of ligand donor atom to which the metal is directly bonded. Just like, for example, PTCl6. In PTCl6, how many chlorine atom is attached with the chlorine ion is attached with the platinum ion here? Now 6 chlorine. So coordination number is 6 here. And in case of nickel, NH3 whole 4. NH3 whole 4. So how many ammonia is attached with that? 4 ammonia is attached with that. So what is the coordination number of nickel here? In nickel here 4. So what is the coordination of platinum here? 6. Similarly, in the complex ion, that is oxalate C2O4 whole 3 Fe. So in case of COEN, EN means it is ethylene diamine condition. That is called EN. In brief, we are saying EN. So EN3, the coordination number of both iron and cobalt is coming here 3. All of you can see. And in case of FeC is 6 because in case of C2O4, C2O4 it is coming oxalate. So oxalate mein how many are there? Already I have shown you. C2O4 oxalate is coming here 2. So C2O4 jab oxalate is connecting or ligating. So here instead of 2, instead of 1, we have to consider here coordination number 2. In case of ethylene diamine, here I have already drawn that one, ethylene diamine, this one. So ethylene diamine, we can see here coordination, here dentate hits 2 here, 2 dentate, didentate condition. So that's why coordination number instead of 1, we have to consider here 2. So in that sense, you can see in case of ApC2O4 whole 3, here 1 oxalate के लिए 2 dentate condition, 2 dentate. So that's why coordination number is totally 6 here. Here it is coming En whole 3. So En is ethylene diamine. Here also didentate condition. So that's why the coordination number 3 into 2, that is coming 6 here. Okay, otherwise those who are unidentate condition, they are coming with a 1 means the number depend upon the number of surrounding atom. Now it is important to note that here the coordination number of the central atom or ion is determined only by the number of sigma bonds formed by the ligand with the central atom or ion. Pi bonds if formed between the ligand and the central metal atom are not counted on this purpose. Okay, that we will discuss after. Now we are coming for the coordination sphere and coordination polyhedron. So the central atom or ion and the ligands attached to it are enclosed in a square bracket and is collectively termed as the coordination sphere. That is actually called coordination entity also. So that's why the central metal atom as well as or ion as well as the surrounding ligand, the ionizable groups are written outside the bracket and are called the counter ions. Okay. For example, in the complex K4FeCN whole 6. So in the third bracket, who are present here? Or the square bracket, that is third bracket or square bracket. So here it is coming about in the complex K4FeCN whole 6. The coordination sphere is which one? FeCN whole 6 4 minus, and the counter ion is K4, K plus. Okay, so this is actually we have to learn here. So here K4 FeCN whole 6. So what is present in the box means it is coming about the square bracket, that is called the coordination sphere. So FeCN whole 6 and 4 minus with charge, that is actually called the coordination sphere, and counter ion is actually K plus. So why it is coming 4, that also we'll discuss, because here 4 is coming, so definitely 4 plus will be coming. 6 it is coming, Cn is coming here 6 minus and Fe is plus 4, and that's why it is coming 6 plus Fe is plus 2. So 6 minus 2, that is coming here, minus 4 is coming, to minus 4 to balance to minus 4, K4 is added here. So that also we will discuss. Next one, the special arrangement of the ligand atom which are directly attached to the central atom or ion defines as a coordination polyhedron about the central atom. The most common coordination polyhedra are octahedral, You can see that one octahedral condition, and it is not given here. So octahedral, square planar, this one is square planar condition, and the tetrahedral, this one is tetrahedral condition. And this is coming about the, for example, CONH3 whole 6, so 6 is there, that means it is coming octahedral. NiCO whole 4, that is tetrahedral, and PTCl whole 4, PTCl 4 and 2 minus, that is square planar. So why Cl4 here also, CO4 here also, why it is coming square planar, why it is tetrahedral, that also we'll discuss afterwards, that is we have to explain it. So now just we have to show here that what is the shape will be coming, the special arrangement will be coming there, shows the shape of the different coordination sphere. As oxidation number, what is the oxidation number here? The oxidation number of the central atom is a complex, is defined as the charge it would carry if all the ligands are removed along with the electron pairs that are shared with the central atom. So now just we can see, just example, CuCN4 3 minus, so this is actually what is coming to us, the coordination complex that is given to us, a coordination sphere that is given to us. So this coordination sphere, so in this coordination sphere 3 minus charge is coming outside the square bracket, and CN4 Cn is charge is -1, so it is -4, so -4 and ultimate total is coming 3 minus, so definitely it will be coming +1, that's why it is coming 3 minus, so that's copper is coming with +1 charge. So that is, in that way we can find out the oxidation number of central metal atom. Next one, we are coming homoleptic and heteroleptic complexes. In which a metal is bound to only a one kind of donor. Here ammonia is one kind of donor, that's what is called the homoleptic condition. CONH3 whole 6, known as homoleptic. Complexes in which a metal is bound to a more than one kind of donor, that is called the heteroleptic condition. CONH3 whole 4 Cl2. Here ammonia bhi hai, chloride bhi hai, that's what is called the heteroleptic condition. Okay.